The random variable x has a discrete distribution. The probability that it takes a value other than 13, 14, 15 or 16 is negligible. We could write the last sentence like this. The probability that x is none of these four values is approximately 0, but not quite 0. But since it's negligible, we might as well say that it's equal to 0. So that means that the sum of the probabilities that x takes on the values 13, 14, 15 or 16 must be 1. Complete the probability distribution table below and hence calculate the expected value of x. So the sum of this second row of the table must be 1. So to calculate this value here, we just get 1 minus the 3 values shown, and we get 0.038. To get the expected value of x, we multiply each value of x by its corresponding probability and sum all the results. So we have the sum of x times the probability that the random variable x takes on that particular value x. The particular value of x is denoted by small letter x. So we have 13 times 0.383 plus 14 times 0.575, etc. We get 13.663, which is the average of the values that the random variable x takes on in the long run. If x is the age in complete years, that means to the nearest year, on 1st of January 2010 of a student selected at random from among all second-year students in Irish schools, explain what expected value of x represents. Well, the expected value of x is just the mean age of all these students. If 10 students are selected at random from this population, find the probability that exactly 6 of them are 14 years old on 1st of January 2010. Let little p be the probability that one of the 10 students randomly selected is 14 years old. We know from the table that that probability is 0.575. Let capital Y be the number of 14-year-olds from the 10 students selected. So little n stands for the number of students selected. Little n is 10. Then we know that the probability distribution of y is binomial. So we have a binomial distribution, and the probability that y equals some value, which we can call little y, is ncy p to the power of y times 1 minus p to the power of n minus y. Now we want the probability that exactly 6 of the 10 students were 14 years old on 1st of January 2010. So we want the probability that y equals 6. N is 10, so we have 10c little y, which is 6, times p, which is 0.575, to the power of little y, which is 6, times 1 minus p. 1 minus 0.575 is 0.425, and we have to raise that to the power of n minus y, where n is 10 and y is 6, so 10 minus 6 is 4. So 6 students, we want 6 students to be exactly, we want 6 students to be 14 years old, and we want the remaining 4 of the 10 students to be some other age. That probability is 0.425. Now we want our answer correct to 3 significant figures. So we have 1, 2, 3 figures in our answer here. In other words, we want our answer correct to 2 decimal places. We get 0.25. So this is the probability that exactly 6 students out of 10 randomly selected students are 14 years old.